Within the world's oceans, large circulation patterns move water from one ocean to another. Off of the east coast of the United States, the Gulf Stream plays an important role in moving water from the warmer southern waters to the New England coast. Within the Gulf Stream, spinning water masses known as eddies break off and transport water towards or away from the coastline. The two types of eddies are distinguished by the direction of the spinning water within each. Anticyclonic eddies push warm surface waters to depth with clockwise movement, and cyclonic eddies pull cold deep waters towards the surface with counterclockwise movement. Previously, warmer anticyclonic eddies were thought to be the equivalent of ocean deserts. However, they were recently found to be feeding hotspots for one of the most heavily exploited sharks in the Atlantic Ocean. Fisheries in pelagic or open ocean waters provide more than 80% of fish consumed by humans, but are difficult to track and regulate. Current management strategies use scientific models that predict where and when fish are most vulnerable. However, these models are generally static and do not consider changing ocean conditions or circulation. In an effort to pair these biological and physical interactions in the Atlantic Ocean, authors used a combination of satellite tags, satellite imagery, and modeling. Blue sharks, an important predator and one of the most heavily exploited sharks in the Atlantic Ocean, were studied. Satellite tags attached to 15 individuals recorded their locations and various water properties such as temperature, salinity, and depth. This information was paired with sea surface height from satellites. Sea surface height indicates the type of eddies present at a given time, where higher sea surface height is associated with warm water anticyclonic eddies and lower sea surface height is associated with cold water cyclonic eddies. Models using all of these measurements were then created to determine if there was a pattern in the blue shark feeding or foraging behavior associated with either anticyclonic or cyclonic eddies. The authors found that the blue sharks were significantly more likely to be found in the center of the anticyclonic eddies than in the cyclonic eddies. In the anticyclonic eddies, the blue sharks were likely to be foraging and were found to dive deeper and longer. In fact, even cold water cyclonic eddies originating from warmer areas in the ocean were found to have deeper dive times associated with blue shark foraging behavior. Both of these findings suggest temperature is an important regulator for blue shark foraging behavior with a limit of 12 degrees C within eddies. Because anticyclonic eddies and warmer cyclonic eddies have higher temperatures at depth, blue sharks are able to dive deeper for longer to look for prey in a part of the ocean that they would otherwise be cut off from. These deeper and darker waters may provide fish that are generally too deep for the blue shark to access. Therefore, these warmer spinning water masses provide important foraging opportunities for blue sharks. Previously, warmer clockwise spinning anticyclonic eddies were considered to be the ocean deserts with low production compared to the colder counterclockwise cyclonic eddies. This study found anticyclonic eddies provide an important feeding opportunities for the heavily exploited blue shark. Pairing physical eddies with biological blue shark foraging behavior reveals previously unknown ecologically important habitats that could otherwise be overlooked. Future ocean management strategies should consider using more dynamic models like the one used in this study to consider how changing ocean conditions affect fisheries. This post was originally made on August 28, 2019 by Samantha Setta. It was titled, "Does Ocean Circulation Provide Prey for a Top Ocean Predator?" and featured a paper by Braun et al. 2019 titled, "Mesoscale Eddies Release Pelagic Sharks from Thermal Constraints to Foraging in the Ocean Twilight Zone." This has been Oceanbites Out Loud. Check out oceanbites.org for this post and other cool posts. Thanks for listening.